Alright guys, so I'm hoping to make this video pretty quick so that it doesn't take too much time so that you guys can get started on the homework. But anyway, let's dive into this. So today, 1.5 notes day 3, still doing multi-step solving, but now we have to add in the justifications of why we do things, okay? Let's first start with reviewing this last homework question from 1.5 homework day 2. Okay, I just kind of wanted to go through this because many of you may have just solved for p in this problem, but you actually didn't have to solve for p. Instead, what we could have done is we could have just plugged in the numbers that they were talking about. So if we plugged in 4, it would be 40 minus 2 times 4 is equal to 6 times 4 plus 8. And then as we go down through this and solve it, we get 40 minus 8 is equal to 6 times 12. 40 minus 8 is going to give us 32, and then 6 times 12 is going to give us 72. As we can see, these two things are not equal, so p equals to 4 is not a solution. Okay. Going through this the other way, okay, p equals to negative 1, we just do the same thing, so 40 minus 2 times negative 1 is equal to 6 times negative 1 plus 8. Okay, so that gives us 40 plus 2 is equal to 6 times 7. So that's 42 on the left side, 42 on the right side. So p equals to negative 1 is a solution. Okay, so this, guys, is actually a great way to check your answers. So say you get p is equal to negative 1. Then you can just double check your answer by plugging that value back into the original equation and then making sure that the left side is equal to the right side. Okay, so it's a great way to check your solving equations problems. Alright, so let's take a look at this next problem. So if we were going through this to solve it, okay, we can see here that there's a negative. Okay, this negative has to get distributed in to the parentheses. So we have 1 minus m is equal to negative 7m plus 1 plus 6m. Okay, from here we're combining like terms, negative 7 and 6m. So 1 minus m is equal to negative m plus 1. Okay, and then if we add this m to the other side, we get 1 is equal to 1. Okay, so that's kind of weird. All of our variables disappeared and we just got 1 is equal to 1. This is an extremely special case, okay? And what we would write in this case is all real numbers, okay? Or on the air test, you'll see it as infinitely many solutions. Okay, so these are both great answers when you get to this problem. Okay, why is this an answer? Okay, this is an answer because if we look at this previous step right here, it doesn't matter what number we plug in for m, right? If we plug in 2 here and 2 here, it's going to be 1 minus 2, which that would give us negative 1. And then it would be negative 2 plus 1. That's going to give us negative 1. Okay, so 2 works. What if we plugged in 1, right? 1 minus 1 is 0. Negative 1 plus 1, that's also 0, so 1 works. Okay, well, let's try a negative number then. Negative 1, right? So if we plug negative 1, 1 plus 1 minus negative 1, that would be 2. Negative negative 1 is 1 plus 1 is also 2. Okay, so as you can see, there's a lot of different numbers we can plug in. So this is a special case. So there are different types of solutions. When we get one solution, it's just x is equal to some number, say negative 5. No solutions actually looks really similar to infinitely many solutions. The only difference is it would be like any number equal to a number that's not it, right? So negative 3 equals to 10, that's not a true statement. Okay, so whenever you get this, your answer would be no solution. Okay, so a little hint here is that the variables cancel. So variables cancel. And then same thing for infinitely many solutions, but this time they're the same number. Okay? So, let's talk about justifications, guys. What you would need to write for justifications is actually just physically saying what you're doing. So, these are all Carnot properties of equality, okay? So the addition property of equality is just talking about adding the same thing to each side, okay? Subtraction, subtracting from each side. Multiplication, multiplying to each side. And then division, dividing by each side, okay? There are other properties, or not other properties, but there's other justifications that we could use, right? We have something called the distributive property, and that's where we distribute numbers, okay? We have combining like terms, and then we also have simplifying, okay? So those are some other justifications. On a test, guys, on our next test, I believe that this is it would be a drop-down menu, so you don't necessarily need to memorize the property name exactly, okay, but it's good to know. It's good to know. So, let's do this first one. In this first one, in order to solve this question, the first thing we'd have to do is subtract 4 to each side. So then we come back up here, we say, well, which one is subtraction? This one right here. What's that property called? Subtraction property of equality. Okay, so that's what we would have to write in our justification. So we write the answer here. So we have x over 3 is equal to positive 3, because 7 minus 4 is positive 3. Our justification for getting to that step is that it is the subtraction property of equality. Okay, so, and then the next step here that we would do is multiply by 3 on both sides. When we do that, we would get x is equal to 9. And then the property we use there is the multiplication property of equality. Okay, and I'm going to show you how you guys can kind of simplify those so that you don't have to write it out the entire time, every time. But you do need to say it's a property of equality. That's super important. Okay? So, let's take a look at this next one. This next one, the first thing that I would do here is I would do this, right? Negative 4 plus 4x. Well, what does that give us? Those two things are just going to cancel, and we're left with 8 is equal to 2x minus 4. Well, what did we do right there? We combined like terms. So that's combine like terms. Okay. In my next step here, I think I would add the 4 to the other side. So when we do that, 8 plus 4 is 12 equals 2x. What did we do in that step? Well, that would be our addition property of equality. Okay, so this is a great way to shorten up your writing. So add prop of eq. Okay, so if you want to shorten it up, by all means do that. And then the last step here, guys, right, we would divide by 2 on each side. We get 6 is equal to x. So what was that? That's our division property of equality. Okay, and so that's all you have to do, right? It's literally just justifying or explaining the step that you did in words instead of just math, okay? And that's something that we'll have to do come the Unit 1 test, so it's good to be prepared for that stuff. As always, guys, if you have questions, please shoot me a message on Canvas or on email. I look at those all the time. And yeah, good luck on the homework.